Europa, one of the most fascinating moons of Jupiter, has been captivating astronomers for centuries. Unlike Earth, which orbits in the Goldilocks zone, Europa's location might seem like an unlikely place for life, yet it remains remarkably warm. How is this possible? The answer lies in the immense gravitational interactions between Europa and its giant parent planet, Jupiter. The immense gravity of Jupiter, along with the pull from its other moons, generates tidal forces that warm Europa's interior. This has led scientists to speculate that beneath its icy surface lies a vast, hidden ocean, a potential reservoir for life. This idea has intrigued astronomers and scientists for a long time. From the time it was discovered in 1610 by the famed Italian scientist Galileo Galilei, Europa has been a subject of intense fascination. Yet it wasn't until the Voyager spacecraft missions in the 1970s that significant clues emerged, suggesting that there might be more to this icy moon than meets the eye. Voyager's images revealed surface features that suggested geological activity that could be linked to an ocean lying beneath Europa's frozen crust. The concept of an ocean world sparked the imagination of both scientists and the public alike, igniting a new era in the search for extraterrestrial life. Fast forward to the present, and the James Webb Space Telescope, JWST, has taken our exploration of Europa to new heights. With its remarkable 10-hour observation of this distant moon, the telescope has provided us with unprecedented insights. But what did these detailed observations reveal? Could Europa's ocean harbor life? What secrets might lie in the depths of its icy shell? Let's explore how these latest findings could reshape our understanding of Europa and potentially offer clues about life beyond Earth. Europa is not just any moon, it's one of Jupiter's 90-plus satellites, making it part of an intriguing collection of moons that orbit this mighty gas giant. Of all these moons, Europa stands out as the sixth closest to Earth. Along with Jupiter's three other largest moons, Io, Ganymede, and Callisto, Europa was discovered in 1610 by Galileo Galilei. Using a telescope he crafted himself, Galileo uncovered the first ever known moons orbiting a planet beyond Earth. These moons, now called the Galilean moons, marked a groundbreaking moment in the history of astronomy, forever changing our understanding of the solar system. Europa's surface is a landscape that intrigues scientists. It's primarily composed of silicate rock and is covered with a thick layer of water ice. The moon's atmosphere is incredibly thin, and is mostly made up of oxygen, though it's not breathable by humans. Beneath this icy shell, however, there's much more to discover. The moon's surface is crisscrossed with dark reddish-brown cracks and lines, hinting at a dynamic, ever-changing environment. These cracks are thought to be the result of the movement of ice, possibly driven by the vast ocean lurking beneath. Geologists have discovered that Europa's surface is relatively young, estimated to be no more than 40 to 90 million years old, a blink of an eye in geological terms. This suggests that the surface is constantly being reshaped, perhaps by processes similar to ice volcanism, or the movement and shifting of ice due to the gravitational tug of Jupiter and its moons. Now, beneath this icy surface, an astonishing discovery awaits. Scientists believe that Europa harbors an ocean that is twice as massive as all of Earth's oceans combined. This ocean is kept warm by the tidal forces generated by Jupiter's immense gravity. This environment is thought to be one of the most promising places in the solar system to search for life, aside from Earth itself. Could microbes or other life forms exist in this salty, subsurface ocean? This possibility has long fascinated scientists. Europa's ocean has been the subject of speculation for decades. In 1972, early spectroscopic studies revealed that much of the surface was composed of water ice, hinting at the presence of water below. Thermal models in 1971 suggested that there might be a liquid layer of water beneath the surface. But it wasn't until the Voyager spacecraft missions in the late 1970s that we got our first glimpse of Europa in high resolution. These spacecraft flew past Jupiter and captured images from a distance of about 1.2 million miles, 2 million kilometers. These images revealed an incredibly smooth surface, with a few faint scars and ridges. The lack of large impact craters suggested that the surface was young and possibly continuously renewed, perhaps due to activity in the interior. In 1989, NASA launched the Galileo spacecraft, which would go on to conduct extensive studies of Europa throughout the 1990s. Galileo's mission was pivotal, providing detailed data that confirmed the presence of a magnetic field around Europa, indicating the existence of a large, electrically conductive ocean beneath the ice. This discovery was one of the first clear signs that Europa's ocean was not just a hypothesis but a real possibility. Additionally, the Galileo mission found that Europa's ocean could hold more than twice the amount of water than Earth's oceans, a staggering amount that piqued the interest of astrobiologists around the world. Despite the exciting findings from Galileo, scientists still had many questions. They wondered about the nature of the ocean's chemistry, and its potential to support life. In 1998, NASA launched the Hubble Space Telescope, which observed Europa's atmosphere and, intriguingly, found hints of water vapor, possibly from plumes of water shooting up from the surface. This discovery further fueled speculation about the dynamic processes occurring on Europa and sparked interest in sending future missions to study these plumes more closely. Fast forward to 2019, and NASA's James Webb Space Telescope, equipped with advanced technology far surpassing previous telescopes, began to observe Europa. On January 9, 2023, the JWST conducted a 10-hour observation of Europa. The data collected during this time was used to analyze the composition of the Moon's surface and search for signs of plumes or other forms of activity. Though no plumes were detected during this observation, scientists remain optimistic that plumes could be variable, possibly appearing only at certain times or under specific conditions. As Dr. Heidi Hamel, an interdisciplinary scientist on the JWST mission, pointed out, there is always the possibility that these plumes are variable and only visible at certain times. But the James Webb Telescope didn't only search for plumes. One of its most exciting findings was the detection of carbon dioxide on Europa's surface. Carbon dioxide is one of the building blocks of life, and its presence on Europa raises intriguing questions. Where did this carbon dioxide come from? Could it be linked to chemical or biological processes occurring in Europa's ocean, carried up through vents or cracks in the ice? Geologists speculate that this carbon dioxide could have been delivered to the surface through a phenomenon called chaos terrain, a geologically active region where ice blocks, cracks, and ridges indicate an ongoing interaction between the surface and the ocean below. The carbon dioxide discovery is significant because it could suggest that Europa's ocean might be capable of sustaining life. Carbon dioxide, when combined with water, forms carbonic acid. This can then break down into bicarbonate and hydrogen ions, which could influence the pH levels, temperature, and chemical composition of the ocean. These factors, in turn, could provide the necessary conditions for life, or at the very least, the building blocks of life. What makes this even more intriguing, is that the region where carbon dioxide was found is close to Europa's equator. This area, known for its chaotic terrain, covers about 12% of Europa's surface and is one of the most geologically diverse regions. It's a prime candidate for future exploration, as it may hold the key to understanding the connection between Europa's surface and its subsurface ocean. If this carbon dioxide is indeed linked to biological activity, it could be a sign that Europa's ocean might be habitable. Organic molecules, essential ingredients for life, could be forming in the ocean, and chemical reactions could be happening that support the possibility of life. These organic compounds could eventually combine to create amino acids, nucleotides, and sugars, molecules crucial for life as we know it. To explore these tantalizing possibilities further, NASA's upcoming Europa Clipper mission will be key. Set to launch in the 2020s, Europa Clipper will perform multiple flybys of Europa, closely examining its surface, atmosphere, and subsurface ocean. It will use cutting-edge instruments like spectrometers, radar, and cameras to search for signs of habitability and potential life. This mission could be the key to unlocking the secrets of Europa's ocean. Simultaneously, the European Space Agency's Jupiter Icy Moons Explorer, JUICE, mission is also preparing to study Europa, as well as two other fascinating moons of Jupiter, Ganymede, and Callisto. JUICE will arrive at Jupiter in 2031 and will carry out a series of flybys to gather critical data about the moons and their potential to support life. As our missions to Europa continue, we may soon answer one of the most profound questions of our time: could life exist on other worlds? Europa, with its vast ocean, chemical ingredients, and dynamic environment, is one of the most promising places to search for answers. Thank you for joining us on this incredible journey through the wonders of Europa. If you're eager to learn more about the mysteries of our solar system and beyond, click on the next video to continue exploring.